So, welcome. Thanks for coming. My name is Lóránt. I work for Prezi, and with my colleague Balázs, we would like to take you through a little tour of the build system we built on Gradle in the last half year at Prezi to create these large-scale modular client-side applications in JavaScript and for the native platforms like iOS and desktop. A couple of words about Prezi. We develop a cloud-based presentation software. We have about 40 million registered users, and we have like 80 developers working in highly independent small teams on our about 2 million lines of code, roughly. And we want to grow quickly, so that's about the company. And we started using Gradle about 1.5 years ago, but not really professionally. I would say we started really doing stuff about half a year ago when we started building this system. Before that, we used to, at least the client-side developers used to work on this huge monolithic Flash application, and it was a huge pain, I guess. Anybody who worked with a huge monolithic application knows that. We tried to modularize it at some points, and it just fought back, and well, we gave up. And luckily for us, Flash is dying, and we need to do some new things. So this time we wanted to get it right. So we tried to plan things, and here's what we came up with. So let me walk you through first of how we wanted a day of our developers to look like. So suppose you're one of our employees, right? And you wake up with this great idea in mind. So we are missing some lines, but that's a house. And you wanna implement this feature, right? So you get to work, and I'm really missing a clicker. Anyway, so and you start working on this beautiful modular application, and we are also missing some colors there. Never mind. So it's modular, it has dependencies and everything, so you start cracking on one of the things. You maybe make a branch, or maybe, I don't know, you just start doing stuff, and at some point you realize that you also need to make modifications in another module to make things work, and your feature is taking shape, so you want to show it to someone from product, like to Jeff, who's working from home today. So what you do is you deploy your changes to Prezi.com, but in a way that only Jeff can see it, right? And he checks out your changes, and he really digs them, and he has some quality feedback, which again triggers you to build some more stuff and invite a colleague from another team, and together you're working, and everything is in flux, and your build is broken right now, and your tests are not running and everything. And then somebody from PR comes in, and she's like, oh my god, we had this big feature release yesterday, and there was a bug we had to revert, and it's okay now, and everything's fine, but we can't move forward until this bug is fixed. So could you be so sweet to take a look at it? So you're so sweet, so you look at it, which means abandoning this ruined workspace that you have and creating a new one and checking out the bug. And it turns out it's not really a big problem, so you just fix it on the spot. You deploy the stuff to the public website, if I can click, and then it's already noon, and as the hero of the day, you invite your colleagues to our awesome canteen, and everybody's really happy. So that was the plan when we set out to create this development environment and build system and everything built on Gradle. So how can we formalize these requirements a little so that they can be acted upon? So first of all, what we needed was quick and safe to get quick feedback from internally in the company and from externally from our users. So we needed to be able to quickly deploy new versions of the application several times a day, and to choose whether we wanted to publish it to the outside world or not. Secondly, we wanted to enable our developers to work independently, either by themselves or together with their colleagues as teams, so they could branch off completely and do major refactors, or they could try some prototyping, which they could abandon completely without ever influencing anything in the main line of development, right? And as we started working on this, we realized that if we wanted to do this modular architecture, we needed extra tooling to support the local development workflow for our developers to stay efficient and agile. So, and we also needed this whole thing to scale up regarding the number of developers. What did I press? And the number of modules that we have, because we want to grow. So what did we actually do? First of all, let me walk you through the quick feedback part. So we have modules, right? And they depend on each other, pretty standard stuff. One of the first decisions we made was that we wanted our teams to be able to work independently, so they could just focus on the module or the modules that they own. To support this, we decided that every single module is going to live in its own GitHub repository. This is quite different to what some other companies are doing, like keeping everything in one huge repository. We used to do that, didn't like it, so now we wanted to try something truly modular so that we can take these applications apart and put the modules back together and form new applications. And we saw that having different histories, different repositories for every module was key. And this gave us a lot of advantages, but it also presented us with a lot of challenges, as you will see. So how do we make these modules depend on each other? Well, we are using semantic versioning. We depend on basically the major version number of a module, meaning that whenever you push a change to a module and we build it, the changes instantly become available to any dependent module unless you're breaking the API, breaking backwards compatibility. So when you push a change to for example, a Canvas module, we assign a version number to it. We use git describe, if you're familiar with it. The main point is that we have a sequential, unique version number by this. We're using Jenkins to build our module, which is like, yeah, we don't like Jenkins, but nobody knows anything better, so we're using Jenkins. And that's it. And we deploy everything to Artifactory once we built it, which is pretty standard. What is, I think, less standard is that once the build has been done on a module and the tests, some rudimentary tests have been finished, we already deploy the build artifact, the build JavaScript to do the CDN. And we do this for every of our modules. So whenever you change something, it instantly, or like in 1 or 2 minutes, because we have these small modules, they get published to the CDN. Because we have the version number in the URL, users don't know where the JavaScript is, so they cannot access it, but it's already out there. And so this all dynamic dependencies between the modules is really great when you're developing the application, but when you want to maintain an application that is out there, you want to know exactly which version of which module is out there, and so you can revert to previous versions, and basically you have control over what happens. So we have the application, which is just a JavaScript file. I don't know if you can read this. Oh, I can zoom in, cool. So it's just a list of modules and what actual version URL can we download that from. So that's what ties everything together. And what we gain with this is, wow, interesting colors. What we gain with this is that because we have these small modules, they build in like 1 or 2 minutes, we can deploy a new version of the application which points to this new changed version of the module, and right after that, in like 3 minutes tops, we can send around URLs inside the company, we can show it to product, we can check it out ourselves in the production environment, and it works pretty cool. And after that, of course, we run a lot of more complicated tests, like acceptance tests and everything, to make sure that we don't deploy to users something which is broken and which could have been tested automatically. But the general idea is that we want to be able to very quickly get feedback from what we deploy. Okay, so that's about how you can work on the main branch, how you can do quick fixes, how you can check your work easily. But what if you wanted to move away for a longer period of time? So suppose you have this little application. There's a network module, there's something that loads fonts via the network, that a canvas that you can draw to, and a text renderer that can actually pull some information from the fonts and draw the text on the canvas. So you want to perhaps implement some kind of feature in there, maybe Indic language support or something like that. So you start working on the text renderer. You still want to depend on the mainline versions of the canvas and the font loader, right? This is done by Gradle automatically. You can just create a branch of the text renderer and start working, and it's going to pull in those dependencies from Artifactory or whatever is your choice of external repository. Things get more complicated when you want to work on multiple modules. So like you also want to change the font loader because, I don't know, for Indic text management, you need some extra information from the font. So you can make changes to the font loader, and it's going to depend on the network, but it's not really good because your text renderer is still going to depend on the mainline version, right? So instead of that, what you want is, yes, it's visible, good. So what you want instead is that the text renderer depends on your modified branched version of the font loader, right? So what we want to do for this is something we call super branches. Super branches are just simply branches which exist in multiple repositories. And what we want is to attach extra artifact metadata when we publish something from a branch, saying that, hey, I am an artifact that is published from the feature X branch or something. And when we do dependency resolution, we want to be able to first try to resolve artifacts from or dependencies from the same branch. And if those artifacts or dependencies don't exist yet, then we want to use the one from master. And maybe we would want to have multiple levels of this. And what Des just said in the previous session, that is going to be possible soon, and we are really waiting for that. So that's about how we want to manage our when our developers want to branch off and try something new, and they want to do unsafe work, basically. Now, all this happens in repositories on GitHub and CI servers in Jenkins. We also faced another problem which happens on your local machine as a developer, and we came up with a tool which I think is probably going to be useful for other people. So we open sourced it. It's called Pride. And well, let me show you what the problem is and how we try to solve it. So if you work with modular applications, you probably are familiar with this problem that, say you're working with these three modules, network, font loader, text renderer, and you're trying to modify text renderer. Gradle is going to be very helpful and download you the font loader from the external repository. But when you try to also make modifications in the font loader, they are not connected. How can you tell Gradle that these two things belong together? As far as I know, the general solution is to use an intermediate repository so that when you make changes to font loader, you do Gradle install. Can you read that? Yeah. And install your local changes to this local repository. And so text renderer can use it from there. And yeah, this works, but it's not really what you want. And also, when you add more modules to the mix, you quickly end up with repeating this strange ritual of going back and forth between directories and doing Gradle install and everything. And also, you don't really get IDE support for this, so the IDE won't know about the connection between your modules. So. Not really nice. So what we would like to have instead is Gradle and the IDE as well to know about how these modules belong together, how they work together, what connections there are between them. So what we do is we create an umbrella project, and when you start working on, for example, text renderer, we make your project a sub-project of this umbrella project, right? It still is going to depend on the external font renderer, so nothing really groundbreaking here. But when you add the font loader project, we can now discard the external dependency on the font loader and tell Gradle that there is a project dependency between these two modules, right? So we call the system Pride, or Prezi Integrated Development Environment. Or you can think of a Pride of Lions if you want. So what we do here is we introduce two concepts: project nesting, so that we nest your top-level project, like the text renderer or the font loader, below a new top-level project, this umbrella project, so that Gradle can see the whole thing together. And dynamic dependencies, meaning that when a dependency is available inside of this umbrella project, then we use a project dependency. If it's not available, we are using the external dependency. So let me show you how this works in practice. So first you need to click. Okay. First you need to create the umbrella project, which is just a directory somewhere. Okay, so Pride is a command line tool, by the way, augmented with a little Gradle plugin, but that we hope that's going to go away soon. Anyway, so you need to initialize a new Pride session, and if you run Gradle, you can see that, hey, there are no subprojects yet, which is just what we wanted. So you want to start working on text renderer, and you want it to depend on the external stuff. So what you do is you go and say, let's go back a bit. So you say Pride add, and you give it the URL of your repository, and Pride is going to clone the Git repository and add the project to this umbrella project. All right, I clicked, okay. And as you see, we have now one sub-project in the multi-project of the umbrella. And if you look at the dependencies, you can see that all three of them are external dependencies pointing to Artifactory, basically. Okay, nothing really cool about this, but as soon as you add the font loader itself, you're going to end up with this. Let me show you how. You just go and add the font loader project, and of course you have now two projects inside the umbrella, and or the Pride, and this is the important bit that font loader has become a project dependency. So why is this the best thing since sliced bread, basically? Because Gradle is able to see the whole project, so you can import the whole Pride into IntelliJ if you want, and it's going to see all your project. If you add a new module or remove one from the Pride, it's going to be able to update your IntelliJ session as well. It also means that when you're doing Gradle install, cd bum bum, Gradle install, cd, you are running a lot of tasks in Gradle, and you're firing up Gradle a lot of times. So this is wasting a lot of time because you're building stuff which you don't actually need and anything. With Pride, with having all of them in one super project, it means that Gradle has one task graph, so it can reason about if you make a small change here to only run the tasks that are actually needed to be re-executed, and it speeds up development a lot. We started using Pride internally like 3 months ago, I think, and yeah, it's a big difference. So it's open source. Oh, sorry, but there's one more thing which is, I think, important. So you can have, with this, it's very easy to set up new workspaces, new sessions where you just focus on like 2 or 3 modules, and you can have several of these sessions side by side working with different branches of the same modules or different modules, and it gives you a lot of freedom to move between workspaces. So yeah, we open source this. There will be a slide at the end of the presentation if you want to check it out, and we'd love to hear your feedback and love to get your experiences about it, and how do you think it works out in different environments. So basically these are the 3 pillars of our build system. Quick deployment means that quick feedback means that we can stay agile. Super branches will help us, because we haven't yet implemented them completely, will help us to be able to work for longer periods of time on problematic, bigger changes, and Pride helps manage the local workflow with these modules and let our developers focus on just a few modules that they actually want to focus on. Please.
How does that work? Do you use it in the continuous integration environment as well?
So the question is if you use Pride in Jenkins. No, we don't use it. So we actually don't want to use it. In some cases it came up that we could use it, but actually what you want in the continuous integration is to always use the external dependencies. So there's no real point in setting this story up. This is for the developers. This is for local development environment management. Yeah.
Does it work with what if you want to import a multi-module build?
So
for example, you have a multi-module build and maybe you have 2 sub-modules in there, each publishing a dependency of their own. Does it recognize that?
Okay, so question was that if it works with so if the modules themselves are already multi-module builds. Yes, it does work. We do have a couple of modules that are themselves have multiple sub-projects in them. There are some limitations. So for example, if your build refers to the root project, so project.root project, that's not going to work because we are changing the root project, right? So when we are nesting your project, which used to be the top level, the root project, we are nesting it underneath the umbrella project, it breaks. Also, when you use like project and give the path, that's not going to work. So we introduced a relative project notation. But the general idea is that it's best to live without these tricks. And if you do that, so if you just refer to projects by name or artifacts by like dependencies and configurations, then everything just works out of the box. Yeah.
Did you have to do anything special with the settings.gradle?
Yes. So basically, Gradle right now has this rule that on top of your build there is a settings Gradle. So what we do actually when you execute pride add, we read through your project that you just added, and we synthesize a settings Gradle on top of it. So the actual settings Gradle inside your project is ignored, and we move every information from there to a merged version of the settings Gradle on the new top level project. And we also need to do some other tricks like setting the version number of the project to like 32K and something like that. We hope that as soon as we have these custom dependency resolution things that we will need for super branches as well, all these hacks and tricks can go away, and we can just have basically nesting these projects automatically. Yep.
Does it handle where a project publishes more than one artifact?
Question is if it handles if a project publishes more than one artifact. Yes, it does.
So how do you map back the artifacts to the correct project?
We map back to artifacts via configurations. So each artifact goes. So we use configurations to talk between projects to publish artifacts from one to the other. We are doing this runtime. Right now it's a little shaky, but yes. So, but we don't have to modify the build Gradles themselves. So there's a, let's call it a bug, which needs to be fixed, because right now we actually do this reconfiguration of the dependencies when all the projects are evaluated, and instead of that, we want to do it configuration time. So like whenever each project is, the problem is that we need to know the group and the name of each project that are in the pride. So we need to wait for them to evaluate first, and only then can we know if they are present in the pride. But we can do this when we add the project to the pride and collect that information somewhere else. So, any other questions? Okay, we'll have some time for more questions in the end. So this was basically what the JavaScript teams are working with now, and I'd like to hand it over to my colleague Balázs to talk about how the native stuff is different and the same, and yeah, exactly sharing build code and build logic between native and JavaScript was the reason why we chose Gradle as our build system, because it's not a self-explaining choice at the first time. So, take it away. Yeah. Just a second. This is coming.
Hi, I'm Balázs, and Lóci just described how our JavaScript build system looks like, and I'm going to talk about our native build system. So first of all, why native? Basically, Prezi wants to help people to share ideas, and for this we need to be everywhere. And it's not just about being everywhere, but also we need to have rich user interfaces on every platform. That also means that we need to maintain different application on each of the platform, because we need different UI, let's say, on iOS than on Android. But what about business logic? It would be nice to be able to share the business logic between the applications. So this was the example application from the JavaScript build system. The only difference here is now we are building on so-called uberlib. I borrowed this term from the Java word. An uberjar basically means a jar file that contains all of its dependencies. And this is what we do right now here, that this uberlib basically will contain all of its dependencies inside one library. The nice thing with it is that if you have such a lib, then you can create bindings for your target platforms, and then you can link this library. And if you write this library in C++, then you can create bindings for this, and then you can link it to your platforms, and this way you can share your business logic between all the platforms what you support. So this is the theory, but let's see how does it work in the context of one module. How can we compile one module to multiple platforms? So right now we support 8 platforms. We also have release and debug types. That means 16 artifacts per module. So how can we handle 16 artifacts per module? For this, we use Ivy configurations. An Ivy configuration for us is an OS architecture and build type mixture, something like this. And when you want to add the dependency for your module, then since we have 16 artifacts, 16 configuration, we needed to write 16 lines of code for each of the module dependency declaration. The upper part is one dependency, the other is another, or the lower part is another dependency. The good thing is that you don't have to do this if we can come up something better. And it would be much nicer to be able to define the target platforms that we want to support with a custom DSL. And also with a custom DSL called binary dependencies, we can say that, okay, this is my dependency and I want this to be applied to all the platforms I support. Or let's say for another dependency, I only want to apply it for the Windows build because it only needed on Windows. And the nice thing is that with Gradle extensions and a little bit of name domain object containers, we can nicely do this DSL. So this is how the build Gradle file would look like. But how does it work under the hood? So how can we do the actual compilation? So for this, we use CMake. CMake is a cross-platform build tool. Basically, the nice thing with it is that you can define your project on a meta level in a CMake file. And using CMake generators, you can generate actual projects from this, like Makefiles or Visual Studio solutions, Xcode, Eclipse, and so on. And then you can use the appropriate toolchain for Makefiles Make, for Visual Studio MS Build, and then you can produce your binaries. What is missing here is that since we are creating a modular architecture, somehow we need to consume the binaries produced by one module into another module. For this, we need some kind of external repository. In our case, this is Artifactory. The sad thing is that CMake doesn't really support this, and C++ Word in general doesn't really support artifact publishing and artifact downloading. The C++ approach is rather compile everything together from source, and then you will have your monolithic applications. But we don't want to do this, so we developed our plugin. It's called Frank. The name is coming from Frankenstein, because we just put different things together. It's a bit let's say, cranky. Also, it's a bit ugly, but it just gets the job done. So how does it work? With the help of Gradle now, we can easily download the dependencies from Artifactory. With the plugin will resolve the dependencies per configuration. It will download it. It will put it into the proper folder in the module, and then the plugin will generate the CMake project. So the nice thing is that right now the developer doesn't have to know anything about CMake. The plugin will generate the necessary CMake files. Of course, if she wants to know, she can do some hacks with CMake and also with the toolchain. But by default, she doesn't have to. And then the plugin will call the proper toolchain. It will build and test it. Another nice thing here is that considering cross-compilation, for example, for Android, now the plugin can create the standalone toolchain for this. Also, it will create the emulator. It will launch the emulator, copy the test artifacts to this, execute the unit tests, and then download the result. And then at the very end, it will publish the binaries to Artifactory. So right now, you can see that why do we call it Frankenstein. OK, that was in the a context of one module and how can we compile it to multi-platform or to multiple platform. But how does it work on the CI? So right now, if you have 16 artifacts per module, then you will need 16 executors. We will have one executor for each of the artifacts. And at the very end, a publish job will collect all the artifacts from the build task, and it will publish it to Artifactory. And this is not just about 16 executors, 16 same executors, but we have to build on different slaves, like on OS X, on Windows, and also on Linux. So for this, we needed to scale up our build infrastructure. We used to use virtual slaves on EC2. The nice thing is that you can easily launch a new slave, you can easily stop, so it's very easy to manage. But we found them very slow. So what we did, we started renting Mac Minis from another provider. So we started using physical machines. And the performance improvement, what we got right now, we can use 4 executors instead of 1, and the build time is 3 times faster per executor, so that's an order of magnitude in performance improvements. But also, if you have to scale up your build infrastructure like this, like you have 16 executors for only one module, then if you have a flaky build infrastructure, let's say you have a bug in your existing build infrastructure, then it's 16 times more likely that it will cause some trouble in your module build. And since we don't want to leave any platform behind, we won't publish the artifacts produced by one particular platform. For example, if it is failing on Windows. So for this, we need proper monitoring and also proper alerting, because we want to know it immediately if we have some problem with the build system, and we also want to act immediately. And so when we thought about it, we considered introducing this alerting mechanism, like I want to wake up in the middle of the night if, let's say, a Windows node goes down, because I don't want my build system to be an impediment for the developer to ship her changes to production. But we thought that maybe at first it would be too stressful for receiving such a wake-up calls. But then we realized that we should, as a tool engineer, we should stress on it and not the developers and not our customers. And what we actually built here is a product. And after we introduced this, that we started feeling that what we build actually counts, and that was an awesome feeling, especially for a tool developer. So if you have 16 executors, then you will need lots of Jenkins slaves. To ensure that we will have the same configuration on all the Jenkins slaves, we use Chef. If you don't know Chef, Chef basically lets you write your infrastructure as a code, as Ruby code, and then you can fire up instances, and it will provision your instances, and it will ensure that you will have the same configuration on all of your instances. So this is how does it work on the server. But since we are talking about multi-platform development, if you are developing, let's say, on a Mac, then probably you want to debug your module on Windows as well. And here comes Vagrant and VirtualBox. With the help of Vagrant and VirtualBox, we can reuse the exact same node configurations, and we can fire up virtual instances on your local machine, and then you can debug your module on your machine. So this was the middle pillar of the JavaScript build system. This architecture enables us to receive quick feedback, to experiment quickly, to create prototype applications quickly. What about the other pillars, like Superbranch? Superbranch, as soon as Gradle has support for this, we will get it out of the box. And what about Pride? Pride, actually, it is working out of the box. We have been using it now for 2 months, and we really love it. So that was the journey at Prezi from a monolithic approach to a modular one. We hope that you find it useful, that you might learn something from it. Also, we love to have your feedback about our approach. You can find us on Twitter, and also we would love to have your feedback about Pride, especially it's open source and it's on GitHub. So if you have some issues with local module dependency resolution, then you might want to try it. Thank you. Do you have any questions?
I have a question. Have you guys looked into using this with non-Git source repositories?
You need to share the mic.
Yeah. Oh.
So this is interesting. Yeah, so we already have a contributor who created some version support. It's not merged yet, but the whole thing is modular, so you can implement Mercurial. It's not really complicated. It's so like Pride subversion support we are talking about. Sorry, I forgot to repeat the question. Any other questions?
Yes. So does it mean that with using Chef we reduce the problem regarding our build infrastructure? Yes, we use Chef for 2 years now, I think, and yes, it helps us a lot. It just ensures that you will have the same configurations, you will have the same slaves.
Is scale bad?
Right now we only use one server, one master server, and the several slaves. So yes, we use it only for heading to production.
But actually the plan is that every single change goes through the same tests and same deployment cycle as if you were working on master and deploying instantly. And we expect to need a lot of Jenkins slaves, but because the dependencies between modules is very lightweight, we can run everything in parallel. So as long as we can add the hardware, we expect that it's not going to be a problem. Yep.
So are you probably not, are you using triggered Jenkins jobs for usually?
Okay, so I think I understand the question. So like, how do we do atomic merges on multiple repositories? The answer is we don't.
Okay.
So that's still to be figured out, basically. Yeah.
Experience this kind of thing, and
yeah.
We're
not.
hard.
Yeah. So I think we are still in the early stages. Like we've been using the system for 3 months, and we are building these big applications line by line. So yeah, must be honest, and that we don't know the answer to that. So right now we just merge one after the other. So like we merge the top level stuff first, and then merge everything after that. So like every dependent module after that. But it's not very convenient. Actually, I don't think Pride should take too much responsibility regarding how to manage Git underneath it, or Subversion.
Not Pride managing.
Yeah.
It's more how does something
Yeah.
know that
No, we don't have a process other than merge the first module, and then if it works, merge the second one, and you can do it like that. But if you have breaking changes, so the idea is that if you make breaking changes, then you
Once you push the first, everything fails.
no, you just bump the major version, and then but it's not very convenient, so probably we need some other tooling for that, but we haven't come up with anything for that problem yet. Any other questions?
I have a meta question. How many tools developers do you have to support 80 developers?
So the question is, how many developers do we have supporting our 80 developers for tooling?
Focused on tools.
How many?
I think 5.
5, 6, something like that.
Okay.
Yeah.
Wow, that's pretty good.
The reason why we have to invest so much, I think, is because we are not working with Java based stuff. So actually, I don't think we have a single thing that is Java based that we build with Gradle. So even our backend Scala stuff is built with SBT. This is just a client side we are trying to use Gradle with, and this means that we need to develop tooling for example, for a language which is called Hex, and it's a weird thing that you write code once and you can compile it to Java or JavaScript or C++ or whatever. We needed to create tooling for that. We needed to create tooling for TypeScript, for example. And as you've seen, we somewhat in parallel to Gradleware, we developed our own solutions for native support, and yeah, so that's why we need to have this quite imbalanced number of developers supporting the others. Any other questions? Or we would prefer lunch. I think it's coming up. Oh, one more.
Other problems have you run into with effectively breaking everything into modules? I know one of the big ones for us is loss of history. So if we have something in one module and we move it to another, boom, all the history for those set of changes is not necessarily preserved.
Well, we try to be careful like we do put in a lot of work to keep those histories when we need to split modules into two or merge them together. So with Git, this is quite doable, I think. I think fragmentation in general is a problem. So like, where do you put documentation? And the solution is, for us, it seems to be search. So like, we now have a service that combs through all the different repositories and tries to collect all the documentation in there and indexes it. So, but again, if you have issues in all kinds of different, so if you are using GitHub issues and keep issues in different repositories, they can get lost. So I think it's more of a logistics problem, and that needs some kind of people-based solutions more than technical ones. That's one of the things. I don't know.
Yeah.
Otherwise it's working out fine for us. I think it's really cool that you can clone stuff very quickly and set up new Jenkins builds for a new module in like this, and instead of like cloning, I don't know, 16 gigabytes of shit every time. Okay.
Yeah, I think here the biggest issue is to finding the module boundaries right. So if you have to make a change, and if you have to make this change always in two modules and not only in one, then that's a problem. And we had issues from this. And also, in this case, you can do this Maven install stuff into your local repository, but right now Pride Pride is a big help for us.
Okay. Let's have lunch. Thank you.
Thank you.